All right, kiddies, you ready to rock and roll? Here we go. Factoring polynomials in quadratic form. So what does that mean in quadratic form? Well, check this out. Watch this. See this guy, x to the fourth minus 5x minus 36? Well, it's not a quadratic. Quadratic equations have the highest power is 2. This has a highest power of 4. But watch this. We're going to be sneaky. We're going to rewrite the x to the fourth as x squared, and we're going to sneak in parentheses in a square. And then minus 5 times parentheses, and inside the parentheses, it's x squared. And then minus 36 equals 0. Now, you notice how in the past, I keep telling you guys that treat a variable like a set of parentheses. Well, we're going to pretend like whatever is in here is just a single variable. It's no longer x squared, okay? Just imagine there's no x squared there. There's just parentheses, okay? If that's the case, then essentially what we have, actually I'm going to go ahead and scratch it out so you can just see. We have something squared minus 5 times something, right? Who cares what that is? Minus 36. In the past, when we had x squared minus 5x minus 36, what we would do is something like this. We would go and we'd do the x, and we'd put minus 36 here, and we'd put negative 5 down here, and we'd make a list of factor pairs over here. And so we're going to kind of do the same thing. We're going to do 1 comma 36 and 2 and 18 and 3 and 12, and we're looking for a pair of factors that multiplies to get us 36 and adds up to get us 5. So I'm not there yet. Maybe 4 and 9. That's looking pretty good. So we'll try 4 and we'll try 9. And then I've got to get a negative 5, so it'll probably be a negative 9. And negative 9 times 4 is negative 36. Always double check that they multiply to get the top and they add to get the bottom. Once we've done that, we can begin to write out our polynomial. Now, the only thing here is that normally what we would do is we would write x plus 4 times x minus 9. But in this case, we know we don't really have an x. In other words, this x is not really an x. If we could lift that up, what we really have under there is we really have an x squared there. Okay, so what we're going to do is make this x squared and make this x squared. Because technically, that's the variable that we're adding to 4, and that's the variable we're subtracting 9. So don't forget to equal 0. And I also want to remind you that you can always check this by foiling and see if you get what you started with. Then you'll know that you factored correctly. All right, anyways, we've done a pretty good job of factoring, and now that we have, we can use zero product property in order to solve. The only thing is that we have not factored completely. I am going to hold you responsible for factoring completely. So let's take a look and see what it means to factor completely here. The x squared plus 4 is not factorable. There was another video that I made where I say that there is no such thing as a sum of squares, so there's no way to factor that guy. If you'd like, you can try, all the different combinations, x minus 2 times x minus 2, x minus 2 times x plus 2. You'll never get that. But x squared minus 9 can be factored. If you want to pause the video and write out the factors, I'd love for you to do that. Otherwise, I'm about to show you right now. It should be x minus 3 times x plus 3. Now that we have the thing completely factored, we can now go ahead and find all the solutions. And one of the solutions will be found by setting x squared plus 4 equal to 0. By the way, the reason for this is zero product property, ZPP. If you still are not familiar with what it is, go and Google zero product property. Essentially what it is if I have something times something times something and it equals 0, then either this is 0 or this is 0 or this is 0. That's all it means, okay? And so what we'll do is we'll set each of those binomials to 0 and then we'll solve. So in this case, we get x squared equals negative 4. And so you should know what's going to happen next. That's going to be x equals the square root of negative 4, and that's a plus or minus. I'm going to do the rest of the work over here. When we have x equals plus or minus square root of negative 4, that's going to get us 2i. Don't forget, square root of a negative 1 is I. So that actually gets us two solutions. And then these other solutions we can see by observation. We're going to also have x is equal to 3 from x minus 3. And we'll see that x can be equal to negative 3. That's from this guy right here. I want to point out to you that we have solved by taking our polynomial, our fourth degree polynomial, and putting it in quadratic form and using the techniques that we learned long ago to factor quadratics. The other thing that's kind of cool is since this guy is a fourth degree polynomial, I want to point out and remind to you that we should expect to get 4 roots when we have a fourth degree polynomial. Now, they don't all have to be real, but we should expect 4 roots or solutions. And in this case, we get 1, 2, and don't forget this plus or minus means there's 2 separate roots there. So we get 2 complex roots and 2 real roots. That's 4 roots. It matches up with the degree of our equation. All right, so that is my example of taking a polynomial and writing it in quadratic form so that we can factor and solve. Yay!